Hi everyone, thanks for checking back in. Well, here we have it. Here's our complete phono preamplifier. Complete from input stage through secondary gain stage to output jacks. Here we have our LM381A. And what we've done now is, well, we've calculated our bias network here, 19.1K and 150K. That allows us, because you see this resistor here is shared between these two input stages, and we're biasing this node right here at about 170 microamps. So there we go. These 250K resistors and our 19.1K resistor and our 6.8 microfarad. There's our biasing network. We've got our potentiometer down here to adjust this rail here to 16 volts DC with a 32 volt, or actually probably we want to set it to 15 volts DC. Anyways, we're going to have about a 30 volt peak to peak output on this thing. So we should have a 10 volt RMS signal possible. What we've done now is we split our gain. The reason that we've done that is because that allows us to set a pole in our secondary gain stage using this network here, which is a combined impedance of about 7.2K and a 1.1 microfarad capacitor. That sets our pole at about 22 hertz for this stage, which gives us, along with this capacitor and these resistors on the output, gives us a two-pole high-pass filter rolling off our lofts, our rumble and wow and all that kind of stuff from the turntable at about 22 hertz. We have a 1 microfarad coupling capacitor here simply because we've got so many other 1 microfarad capacitors. No sense in changing anything. We're using a 10 meg input on this network right here so that our JFET input doesn't go floating and it doesn't load down our RIA compensation network. Here we have our combined 0.08 microfarad capacitor, and here we have our 0.027 microfarad capacitor and our 3.9K resistor, our 27.4K resistor. This is all the RIA equalization network. We have a gain of 10 on our input and a gain of 10 here, which gives us a total gain of 100, which is 40 dB. So we have 40 dB of gain through our phono stage, and we're down to 6.8 microfarad capacitors here on our power supply. We have a common mode choke here to filter our input power, 6.8 microfarad capacitor across the choke, followed by a 100 microhenry inductor and a 6.8 microfarad capacitor for this chip, and a 100 microhenry inductor and a 6.8 microfarad capacitor for this chip. So we have really good power supply filtering. Since we have a 32 volt input power supply, I just happen to be using a Fuzzy Audio TB100 or TB10D, which has a 32 volt power supply by coincidence. That works out well for us. I'm just going to use a Y splitter on my power supply, and I'll power my phono preamplifier from the Fuzzy Audio power supply. If you don't have a Fuzzy Audio power supply and you want to build the circuit, you can buy the 32 volt power supplies off of eBay. They're about $50. They're kind of pricey. Honestly, if you're thinking about building this and you don't already have a good stereo, I would suggest dropping $60 for the whole doggone thing, and you get the Fuzzy Audio power supply, and you get the very, very high quality Fuzzy Audio amplifier for about $60, $70 off of eBay. Our LM381A here is externally compensated through a 100 picofarad capacitor. Here we have our DC gain stage, 4.75K We have a 5K trim pot here, which really we're only going to be using a fraction of the rotation. So that needs to be a 25 turn or at least a 10 turn pot. And we've got our 475 ohm resistor here, which gives us an AC gain, like I said, through the circuit of 10. Our 1 microfarad capacitors on the input. That should give us some roll off of the low frequencies before it hits our primary gain stage. And again, it's all going to work together. This is a pretty good design. I've shared it in the link below. Some of the details may change. This right here, these 15 microfarad capacitors can be Sanyo Oscons, which are very high quality. You don't need a film cap there, although if you want to drop 10 bucks a piece on film caps, you're certainly welcome to. But a 15 microfarad Oscon will do exceedingly well here. I don't believe that you'd be able to tell the difference in the sound from a film cap using an Oscon. Oscons are very high quality, and they have an exceptional good sound characteristic. 475 ohm resistor, 15 microfarad capacitor. Again, we've got a roll-off frequency here of about 20 hertz, so that gives us 1, 2, 3 pulls to get rid of all of our subsonic noise. This should perform very stably, have a very good power supply rejection ratio, and give us really good tight sound from our phonograph, from our turntable. I happened to score a deal just recently on a LSD, on an SLD202 Techniques vintage turntable. I'm anxiously awaiting its arrival, and I'm anxiously awaiting the arrival of all the rest of the parts to build this. I'm going to build one on perf board, and then I'll be laying out the printed circuit board from the layout of the perf board. I kind of work backwards that way. I like building stuff on perf boards. It helps me to visualize where everything should go and how the foil paths should be optimally placed. So that's it for today. Thanks for tuning in, everyone. Be sure to like and subscribe if you haven't yet. I sure appreciate every one of you who tunes in, and I look forward to seeing you all again very, very soon. Bye-bye.